love to welcome to our virtual conference setting Professor Dr. Julia Schnabel from Helmholtz, Munich. She's the director of the Institute of Machine Learning and Biomedical Imaging. Hi, Julia. Great to see you.
Hi everyone.
How are you doing today?
Fine. It's very sunny. I hope the sunlight will be okay. Looking forward to this talk.
Always good weather in Bavaria, right? All right. So before I hand over to Julia and her opening talk, I would love to remind everybody of the chat. You will find it on the left side of the screen. And please do pay attention. There is the big chat that you're utilizing at the moment. We're very happy to see so many people from so many countries there. But there's also a button called Q&A, okay? Since you can only listen and not talk, we would love to invite you all. If you have a question regarding Julia's talk, please put your question inside this Q&A chat. And Victoria here will read said questions to Julia after her talk, okay? So go to the left side, go to the very top, hit the Q&A and put your question there. Understood? Good, you're smart people. And that's enough for me. I'd love to hand over the full stage now to Julia Schnabel and her opening remarks. Julia, great to have you.
Wonderful. I think you can see my screen now, so I'll jump straight in. I was already very kindly introduced. I'm at Helmholtz Munich, where the sun is always shining. It's really a great pleasure to be here. While I'm on the HIDA steering board, I was asked to actually talk a little bit about my career in terms of data science and IT. As you can see, I'm not only at Helmholtz Munich, I'm also at the Technical University of Munich, my university affiliation. Usually these come in a dual appointment, but I also retain, and I'll talk you through that, a part-time post at King's College London. So first of all, a disclaimer, a career is never complete. A career is a journey in the making, and it's very much work in progress, always a little bit of a construction side. As a kind of little intro to myself, where I'm coming from, I'm actually from Berlin, from West Berlin, born in '69 during the Cold War. And '89 was a defining moment for all of us. We just had the 9th of November, the anniversary of the falling of the Berlin Wall. And that actually changed a lot of things for me. And it's sort of one of those moments in your life where you start thinking that now life is really kicking in. So my first stop, I studied in Berlin at the Technical University of Berlin. I did my master's in computer science, but already during my studies, I focused through computer graphics on medical image computing. So there was a master seminar, technical studies in medical image computing, I think it was called, and that attracted me to the field. I really felt this is where computer graphics, computer vision could make a difference, could actually be used for the benefit of humankind. And I did quite well to a degree that the university gave me a little stipend. It wasn't much, but it was enough for me to think about my future. Where do I want to go as a postgraduate student, as a PhD student? It's a little bit what the HIDA visiting research program might offer you. This is kind of the Kickstarter, which was for me. And through that prize money, I actually decided to follow the Beatles, take it to buy my ticket to ride, and head over to London. So I arrived in London in '94 at a really exciting time. It was really the kind of the cool Britannia wave, kind of the slightly spectral opposite of what we're seeing these days. But it was really one of those moments in time where I was really pleased to have this change of scenery. Berlin was fantastic. But due to the German reunification, which officially happened only in 1990, the German job market just wasn't quite there yet. And so further education, doing a PhD seemed to be the right thing. You always want to improve on yourself, educate yourself, and actually improve your chances for your own career in your future. So starting in London, I joined a very small medical image computing group. So I stayed with the theme. I went to computer science department at University College London, where the computing group, a medical image computing group, was just myself and my PhD supervisor, which actually turned out to be pretty good because it was really dedicated one-on-one supervision. And I did my PhD in those 3.5 years or so, 4 years in total, with all the exams and all these other things. And I had my PhD on a topic called multi-scale active shape description in medical imaging. So this was about basic morphometric analysis of brain images, but also other shapes using image analysis. So I was really pleased with that. And at that time, scale space, as it was called, so basically looking at images over different degrees, from the pixel size of an image to the macroscopic structures in images. There was just this one key group in the Netherlands at the time. And I made connections through conferences to that group. They had invited me in. Whenever you cross from London to Berlin, why don't you stop right in the middle in Utrecht in the Netherlands? So I did my postdoc there. Incidentally, I left with my partner of many, many years now to London. I left him in London for a while, just for that year, but we collected a lot of air miles during that year. So it's one of those things which one needs to manage in one's career journey. How do you handle personal relationships, family, all these other things, and we solved it, using normal logistics and air miles. But then, of course, after 1 year, we stopped that, what we called the commuting nonsense. I rejoined London and started a postdoc at King's College London, which was, everybody was working what's called image registration, so basically geometric alignment of different images acquired from different imaging modalities like MRI and CT and X-ray. And I worked on these things called B-splines, so basically almost a little bit going back to my computer graphics roots for a bit. And it was really nice time I had there. It was also a very productive time because I decided a postdoc is actually a good time to think about having my own family. So I had two kids, born with an amazing view on Westminster from the 8th floor of St. Thomas's Hospital. And that's also one thing to think about. Sometimes people always think they need to have their secure job, their final job in place, but actually along that journey of your career, there might be many opportunities to actually start, if you wish to start having a family. The next stop, life does these little spirals. A career is never a linear path. I went to UCL again because my whole group at King's College London was kind of being in one of those unreasonable political decisions being dismantled, and we decided we're not getting dismantled, we're just moving. So we actually made connections to University College London again, and the whole group at King's just merged with the whole group at UCL. And my original group at UCL is just my supervisor and I. We experienced a really unprecedented growth. We were the largest medical image computing group in Europe at the time. And I became a senior postdoc in that time, and I've changed my research focus again a little bit, work on brain image analysis, on Alzheimer's disease, on simulating basically phenotypes of Alzheimer's, but also looking at brain parcellation techniques as well. And it was a very large collaborative project across many universities in the UK. It was between Oxford, Manchester, UCL and Imperial College London. So this was a great way also to build my own network of people. And many of those people have remained my colleagues for all those years. But then was time to grow up. At some point you have to. And I was extremely lucky. I'm not lying. Sometimes it's just luck and coincidence. I came across a job ad in a medical imaging mailing list in the UK. Calling for an associate professorship. At that time, they were called university lectureships in engineering science, with a topic focus on medical imaging at a newly built Oxford Institute for Biomedical Engineering on the hospital side in Oxford. And I applied, and I was offered the job against the odds, which I thought. But what I did then, I didn't move to Oxford because we had our family in London at the time. But I decided, well, let's play it safe. Let's stay in London. We had everything in place what we needed. And I decided I would then commute from London to Oxford, which the train is just 1 hour, but crossing London, crossing Oxford, in total I clocked up 2 hours each way, almost every day in the week. So normally I wouldn't see much of my family during that time, but you have to remain practical. So you have to solve logistics. I got one of those silly folding bikes, the Brompton, really nice piece of British engineering, which you can just take on the train very easy, and then you can cycle all the way. It doesn't go fast, but it goes very far. In fact, I kind of calculated how far it took me in 8 years, and 8 years with the train as well, of course. I've covered about 400,000 kilometers, which is like the distance to the moon. And a normal, typical day, because you have to, get your work life in balance with your family life or other private life. So there were lots of school runs, kindergarten runs, folded bikes in car boots, or cycling straight to stations, to the train station, train rides, my rolling office on the train, marking coursework, or writing on grants, cycling between different sites in town in Oxford, train ride back, school run back, or cycle straight home. It was quite an exhausting time. It felt a bit of a sacrifice, but it all, I think, was totally worth it, because I had this fantastic group there, and it started building my academic career. In fact, it went so well that a couple of really nice things happened. First off, on Oxford, one does a sabbatical. It's something which is in universities sometimes only one semester at a time. There you have to take it for a year, ideally. And I had a really good collaborator in Japan, so I took the opportunity and said, let's go and visit. We timed it with family holidays and other things, collected a few more airlines between the UK and Nagoya University. And that worked out really well. Again, it was also a network opportunity. I visited groups in Tokyo and Osaka, in Nara. So actually, it was a really good way of increasing my network even further. And all these things then started leading into even better things. I was promoted to full professor by recognition of distinction. That's an Oxford way of saying, if you've made it, you're one of us now. And most people would then say, that's it, or professor in Oxford, there's your career, right? You're done. You don't have to do anything anymore. Maybe write some papers, write some runs, but basically now you can relax. And I thought I would, honestly, But as soon as I became professor, I got this phone call from London, and they said, Julia, don't you want to come back? Again, King's College London, where I had been before, was inviting me back, this time to become a professor in computational imaging, and also lead a new doctoral training center in smart medical imaging between King's College London and Imperial College London. So it was a huge opportunity for me to actually help shape the skills training and the research programs of this generation of imaging scientists, which was, very ambitious, but also equally rewarding. Now, leaving Oxford was a really difficult career decision for me. I remember I was drawing up lists with pluses and minuses and trying to figure out what I actually wanted to do. But in the end, it was the right one. I was swapping this 2-hour each way commute to a 30-minute cycle ride. So it was just beneficial for everybody, even my personal health. And I made lots of new and exciting collaborators, clinicians, academics across different London groups. So even if you join one university, you can still collaborate with other universities. Like in Munich now, we're also collaborating with LMU or with Erlangen, or even with the Charité or other places in Germany. But that led into really nice big projects, which I would not have been able to do before, because it just brought more people to the table, more diverse people to the table. We worked on fetal imaging with sonographers, with pediatricians, computer scientists, medical physicists, on real-time ultrasound acquisition and online interpretation using deep learning, artificial intelligence, really making its advances 2015 into our field. On cardiac imaging, smart heart, we called it, where we actually applied deep learning along the entire imaging pipeline, and cancer imaging, looking at early detection of lung and liver cancers. So again, I thought I'm done. I've got huge research programs. I'm based in the hospital, in an engineering department, which is quite unique. But again, then a couple of things happened, and I think I'm just talking about the main thing which happened here, was of course Brexit. So this is something which took us all a little bit by surprise. But even though nothing really changed for me, I could have stayed on and continued to thrive there. But a lot of people started their own Brexodus, and it opened up new opportunities, because all of a sudden across the channel in the EU, in the rest of the EU at the time, people started knocking at doors as well and said, well, you haven't had enough from this Brexit yet. And well, the other thing, of course, which happened was lockdown, where all of a sudden one has a bit of a reset button. One was sent home, work in your basement, studio, apartment, or wherever you people were, and all of a sudden you only see your group like this, remote on Zoom or whatever interface you're using, and using Slack and email and all these things. And people are scattered across 3 continents, in my case, six countries at least. And we started prioritizing personal and lab welfare. So basically, how do we work with each other above work itself for a while? But only that life and work really started blurring into another. I did not know which day of the week we were at for some time. And many researchers, of course, especially early career researchers, those with an uncertain future, with very young family, were and still are at breaking point in that time. So these two things together actually started then making other things possible for me. So again, reoriented, and hopefully my final stop, my 8th stop, is in Munich. And I started as professor for computational imaging and AI in medicine at TU Munich, which was jointly with the so-called Liesl Beckmann Distinguished Professor. Liesl Beckmann was the first female professor at TU Munich. And that's a professorship created for women in particular, kind of giving them additional funding, additional means to attract them to Munich, to attract them to the university. But what that really made financially possible was the Helmholtz Distinguished Professorship, which is aimed at leading female academics, international leading female academics, to lure them back into Germany. And this is what happened with me. And through those means from the Helmholtz Distinguished Professorship, I was able to found and direct a new Institute of Machine Learning and Biomedical Imaging at Helmholtz Munich. And of course, we didn't all leave at the same time. We had a bilateral family commute until we all had settled in. And I wish I would have said we had more air miles collected, but travel restrictions were very, very bad, and lots of PCR tests and mask wearing on the way. But this is where I'm now, final destination. I've never planned ahead for a very, very long time. I always try to keep an open mind where possible and embrace change where it made sense. It's always also okay to say no and say, this is not for me, not the right time. Sometimes change felt a bit like a sacrifice and can be really overwhelming at the start. You have to, I've lived almost 30 years abroad. Coming back to Germany was an interesting change, but I had to kind of get used to it again. But I also settled in very comfortably at the same time. And I've always enjoyed rising to new challenges and building up new research programs. But generally, my career was dictated by a mix of change and personal circumstances, and some really good opportunities just coming at the right time. I also should say I didn't do this alone. I always received a lot of support at home and at work, and that's important. It's something which can be a really lonely ride otherwise. Now, I hope I've got still a little bit of time to actually talk about research at this point. And I want to talk a little bit about the research program I'm building up at Helmholtz Munich. I've started last summer for real, last May, and then with some commuting, and then last summer for real, in the middle of the pandemic. But basically this new institute, which I'm building up, or basically have almost completed building up, but I'm now increasing it, is standing on 4 columns. One is machine learning for advanced biomedical imaging, basically going from the scanner, from the imaging scanner right to the clinical interpretation. The second column is on early detection and for improved therapy and intervention. So basically, can we detect disease as early as possible? Can we move the diagnostic window earlier? The third column is on really big data. So big medical data. Can we actually look at really large population databases? There's a UK version, the Biobank, but there's also the German National Cohort, NACO, where we can really study disease interrelations and comorbidity through imaging, but with additional information, not just images anymore. And then the final big column almost is basically where I want to move all these things towards is really looking more at emerging imaging solutions, really new latest kits of imaging, but also affordable imaging solutions, those which hospitals can afford to buy, those which primary care doctors, practitioners can actually put into their surgery, those which actually could be maybe rolled out to developing countries as well, which are for both the patient and the clinician benefit. And just for the first column, I really wanted to challenge the conventional serial imaging approach where we acquire images, we reconstruct images for viewing, we then do a little bit of modeling or extraction of information, and we present all this to the clinician. I really want to basically take us along this entire imaging pipeline, tightly couple all these different, usually isolated elements, and integrate other, machine learning, but also biophysical models alongside. This could even lead to some active imaging, where we actually, at the time of imaging, decide what kind of images do we need to acquire from a patient. And, the slightly challenging question, can we even do without imaging? Because all the information is acquired at the imaging center. Can we already extract some really vital information at that point without even going through the reconstruction and modeling process, because each of those steps accumulates errors. Here's just one example from our smart cardiac imaging tool, where we actually integrated image reconstruction, motion artifact correction, and segmentation of the myocardium into one big neural network approach, which then improved all these tasks simultaneously. The second silo was on early detection, improved therapy and interventions, where we wanted to deal with diagnostic and agnostic challenges to basically send patients to their optimal treatment plan. And there we want to actually look at new biomarkers of disease. There can be imaging biomarkers, basically features we extract from images, or there could be non-imaging biomarkers like blood serums or other things, and where we actually really stratify patients accordingly. We want to not only predict disease, early detection of, say, lung cancer, for example, but we also want to predict recurrence of disease. So when patients have been treated, will the disease come back, and can be detected as early as possible, again, to move the treatment window to patient benefit. And in the end, we want to go into prevention. This is not where any money sits, because money is made from treating patients and not from preventing patients becoming ill. But in the end, I think it will be for huge societal benefit. Here's just one example where we actually show on the left and the ABC frame some real lung tumor growing over time. That's an observational study. And on the right, we're actually showing how we can actually model a tumor growing. We can actually do that actually from a very early case, can detect how that case would look like in a year's or 2 years time, and then maybe detect lung nodules much earlier than currently. The third column in my program is on disease interrelation and comorbidity. As I mentioned, there is huge studies, population studies, where 30,000, 100,000 and more volunteers from the population who may or may not be ill. They're normally not ill because they volunteer, but some of those have health problems and are then particularly interested in volunteering. They get scanned, but other measures are also taken from them. And this gives us this unique opportunity to relate imaging and non-imaging information again. We can really correlate different diseases together, for example, diabetes with cardiac diseases or cancer, and we can find new diagnostic and prognostic markers, and even discover morbidities. And here on the right and the bottom, you see one example where we're actually exploring liver cancer, where we've got different imaging protocols in MRI. We want to predict quantitative MRI markers. We want to predict the volume of the liver, different structures in the liver, and we can also feed in non-imaging data, in this case, for example, the scanning protocol itself. So we can use that for liver disease characterization, for staging of liver cancer, early stage liver cancer. And then the final column was on emerging affordable biomedical imaging solutions. They wanted to innovate disruptive and affordable imaging across all the other themes. So we want to really push the image resolution limits. We want to become autonomous. We want to do push button imaging, be affordable real time, and basically translated to clinical use. And here's just one really nice example of fetal ultrasound. Well, while we're scanning the ultrasound, we actually predict what structure we can see. We can measure even the circumference of the head, and actually help the sonographer in their work. And this is all I had to say. I'm really looking forward to your questions, which I don't see on the chat, but hopefully they'll be communicated to me now. Thank you very much for your attention.
Amazing. Thank you so much, Julia Schnabel. So, I mean, this is just me clapping now, but I mean, we have 100 people online who listen to you, so you should imagine like a big auditorium now with standing ovations. So
I wish.
There was quite an impressive talk, and obviously we can only congratulate you to this impressive career. And obviously the Helmholtz Association is extremely happy that you decided, with all the opportunities that you had at hand, to actually join our programs. So everybody, let me remind you again, if you have a question dedicated to Julia, please go to the chat to the very top and hit the Q&A button and put your question there. Victoria, I'm pretty sure there are already some questions coming up, right?
Yeah, we have a very interesting first question. So Munich is asking, Julia, what was your key technical skill to have a successful career in data science like this? What skill was the most difficult to learn or obtain?
It's two skills. One was programming, actually, really. And with programming, I don't mean learning a programming language, but learning about algorithmic design, right? How can you solve a problem? How can you break down a problem into smaller parts and actually work yourself through it? Second skill is communication. And it's communication not only like, can you talk to each other, but it's really communicating with the domain experts. So in data science, you don't work just on your own. You don't just, build a model and apply it. You have to actually do it with a purpose. You have to understand what it is that you can contribute to. What's in my case, the clinical end goal? What is it that clinicians need? Can they understand you? Can you understand them? So it's about co-educating each other in that time, and that requires a bit of kind of like lay communication sometimes. Like, I wouldn't say dumbing it down, but making it sound really trivial. They feel the same with me, right? But that's really important. You really have to understand why you do it. And only then you can also break down your problem in the ways that are beneficial for the method.
Thank you so much for this valuable insight. I'm sure there's more questions in the chat.
Yeah, we have another question from Shivan Said. Is asking, what would be your suggestion to the students who have done their first degree in other fields and also have working experience? What route should we take to start a career in data science or academics?
So I would say no data scientist has studied data science, right? We all come from different fields. And that's the beauty of it. That's actually, you have to study deep before you can study wide. I think it's always good to have one really deep skills, whether it's like biology or chemistry or engineering or whatever it is you've studied, right? Then going further, I mean, it requires, as I mentioned, requires programming, but these days I think it's much easier because the tools are there. You can, the learning curve is not as steep as it used to be going into programming. So I think biologists, chemists, they can all learn it. I think especially during lockdown, I noticed that my graduate students in my doctoral training program, especially the chemists who could not go to the lab and do their vital experiment, they said, what can I do to skill myself? What can I do from home? Yeah, and then I gave them tools, methods, books, courses, whatever they needed to actually use that opportunity. It can be a crash course. It could be like this data science courses offered, Ida and partners, to actually learn the skills. But in the end, those are just skills. What you need is to be able to apply those skills to the problems probably from your domain. So I wouldn't say goodbye to you to what you've learned in your first degree. I would actually use that as an advantage, because this is where I think you can explore most.
Mm-hmm. Thank you very much for this recommendation. There's one question always arising with the younger crowd. What would be your suggestion for a first programming language? What would I study in more depth, getting started on?
Yeah, that depends who you ask. I do deep learning, and that means Python. So basically, Python is our bread and butter. And then you need to, that's just the programming language. It's a scripting language. And then you need to use the deep learning libraries like Python, TensorFlow, and so on. Mm-hmm. It's done much easier because there are these Jupyter notebooks, which you can bring up and do almost like visual programming. You see your results as you kind of go through. But I think if you go more into bioinformatics, it would be R or Julia or other tools. Some people still do MATLAB for imaging. It's not too great. I'm still one of those hardcore computer scientists. I did C and C++ and all these things, so I still miss it. But I think Python is probably the one where most of us have settled now in data science. It's never harming that.
All right. Yeah, I started off with C++ as well. Victoria, we have time for one more question.
Yeah, the question is, how important for you and your career was it to spend time abroad? And do you have plans for moving back to the UK? I hope not.
I hope nobody's listening.
From London.
So maybe I started the back first. So I still have a foot in London. I'm also British. I'm a dual citizen. So and my daughter is studying in Scotland. So I still have family roots there as well. But I'm seeing it more as a transitional period right now. I still have a satellite group there, and I don't want to let down. I keep like a low profile there. I'm not teaching anymore, and it's just my little research outlet, my little hobby on the side, basically. Going abroad, it's a two-edged sword because everybody wants mobility. We want to bring researchers via HIDA, of course, to Germany. That's great. So yes, I say you should do it. Not everybody can do it though, and there might be lots of reasons. Mobility is not a family-friendly thing. It's if you're not in that place where you can still move, where it is disruptive to school life or your partner's position, or you've got another caring position in the family, then it can be preventative, right? In which case I would say moving abroad may not always be necessary, but you could build up international collaborations, maybe doing short trips or do it like this via Zoom or something like that. And that would be, I think, enough. I mean, in grant applications or when we shortlist candidates in general, we look for mobility. It's a good thing. It opens your horizons. Traveling is always good. I think it just really, that's what we've been missing, I think, in this lockdown period, and conference only starting again, right? But it's not absolutely necessary. It is necessary when you want to come to Helmholtz and join one of our fantastic labs. I can only highly recommend that. But it's not for everyone. And I think that should be also acknowledged in applications, that some people can't go abroad, but then you should probably do something else. You should probably have some international collaborations which you build up via conferences, via projects or other things.
Okay, thank you very much for this consideration. So Julia, if I was with the younger crowd now and I would be very, very keen now to work for you especially, what would I have to do then? What would I have to bring to the table, and how would I be able to approach you?
So I receive about 20 applications a day. My main challenge is, getting, finding the right applicants and not getting lost, losing new applications in my inbox, right? So that's important. So the email, if you send an email, please don't call me. If you send an email, be quite concise what you want to do and why you want to come, what you would expect, but also what you would bring in. So I think for me, the cover letter is really important because it formulates your research in that field, in my case, machine learning and biomedical imaging. So what it is, and not just as a generic term, really what applications, what techniques, who you would like to work with, be as concise, as precise also as possible, and have a little research proposal, like already present as a project what you think you could work on. And this gives me some initial idea where I could see you fit in. So I can say, yeah, they have done, but we're not doing that right here, but we're doing that, and that's close enough, right? So you've done ultrasound, we do MRI, we can talk maybe, right? And then the communication starts. And through the visiting researcher program, for example, we can actually arrange for these short visits, which are really good. So they can come for a couple of months and almost like as a probation visit, but it's probation on both sides, right? You evaluate me as much as I evaluate you. And then hopefully good things will come from that, because that should be put to good use. To actually develop a mini research program to publish, but also to think about the next career step. Is there a future in that group? Are there more opportunities to stay on, to extend basically on other funds? And that's basically how these things start. I would also suggest, if you're in town, if you happen to pass through, to drop a line in case I happen to be in my office, which is not as often as I want to be, then to actually at least visit the group, talk to my people, talk to my students, talk to my postdocs here, because they will tell you how it really is, hopefully only good things. But usually those people who actually ask that question, whether they could talk to somebody from my group, those were the people I accepted at the end, because they actually had the clear interest to actually getting the full information together and not just, send random emails.
All right. Thank you, Julia, so much, not only for your very interesting talk, the introduction to your career path, and thank you for pointing out the opportunities that the HIDA provides to actually get in contact with you and other leading scientists from our centers. We would love to chat more with you, but time is running and we got the next panel lined up. So let me thank you once again. And to the crowd, there is people from the Munich Data Science School at the Expo Fair later on. Julia is heavily involved there, so you can get in contact there. There's also the Helmholtz AI and the Helmholtz Imaging platform at the Expo Fair. You can get some more insight there as well. And obviously, you can find Julia online or on Twitter. We just found out, so make use of that opportunity as well.